Aldehydes are really important organic compounds. They come a lot, and you really deal with them on a daily basis. You don't really realize it. So let me tell you what is the main thing about the aldehyde. They have this COH. This functional group is called carbonyl. The COH is called carbonyl. And simply a carbon atom and an oxygen atom connected by a double bond. The reactivity of carbonyls is primarily dictated by the polarization of the CO bond, but the surrounding atoms also play a role in specific reaction pathways. While carbonyl is a component of many functional groups, so it's not only an aldehyde, the carbonyl you can find in other also functional groups, it is not itself a functional group. An aldehyde is a carbonyl in which the carbon atom is bonded at least one hydrogen atom. The other group attached to the carbonyl may be an R. So the carbonyl is this part, and when it connects to the H, then it becomes the aldehyde. The other group attached to the carbonyl may be an R group or a hydrogen atom. So it could be carbonyl and hydrogen from both sides. So that's a carbonyl group with two hydrogens. Because the hydrogen atom is so small, the partial positive charge on the carbonyl carbon is very easy for the molecules to approach, making aldehydes a particularly reactive type of carbonyl. Aldehydes are versatile reactant for a wide variety of organic synthesis. We do know the aldehydes from the smell. The one that we know very much is cinnamon. Cinnamon, perfect. So the cinnamon is a type of aldehyde that comes from cinnamaldehyde. Also, vanilla. You know, I'm sure vanilla. Vanilla is an aldehyde, and that's where the vanilla extract gets its smell. So you see now, aldehydes, they actually do play a very important role in our daily life because of their smell. The simplest aldehyde is the formaldehyde, where we don't have here an R, but we have an H. So the formaldehyde is the most simplest aldehyde. It's very special. It has a very wide variety of uses. We used it, if you have done this in high school, where you did the frog, where you keep the frog, you kept it in formalin solution, which is formaldehyde with water. In 1996, production of formaldehyde was estimated at 8.7 million tons per year, mainly used in the production of industrial resins, particle boards, and coatings. If you do one more step, the formaldehyde becomes acetaldehyde. So you get here your first methyl group, and then your carbonyl and the H next to it. The acetaldehyde is a colorless liquid or gas boiling near room temperature. So it is a liquid. However, when you look at it, so I put it once in a syringe, and then it started boiling inside the syringe. So suddenly the liquid disappears, and then it's all gas. Acetaldehyde occurs naturally in coffee, bread, fruits, and is also produced by plants. It is produced by the partial oxidation of ethanol by the liver enzyme alcohol dehydrogenase. For the people who drink alcohol, when they wake up the next day and they have this very, very bad headache, that's actually not caused by the alcohol, but that's caused by the acetaldehyde as a byproduct of the alcohol. Pathways of exposure include air, water, land, or groundwater. It's listed as group 1, that's like a very known carcinogen, so causes cancer. Acetaldehyde is one of the most frequently found air toxins with cancer risk greater than 1 in a million. Now, looking at this graphs over here, this shows you the production of acetaldehyde over different regions: USA, Europe, Mexico, Japan, and China. And you can see that it is produced mostly in Europe. but then the production is really going down, while the production in China is actually going up, being now China is the most producing of acetaldehydes in the world. Next aldehyde is called acrolein. Acrolein is CH2CH. So here we have a double bond, not a single bond. And then you get your carbonyl group and your H. It's a colorless liquid with a piercing acrid smell. Acrolein is actually the smell of burnt fat. So when you are barbecuing and you do smell this nice smell of burn, that comes from the acrolein. It's caused by glycerol in the burning fat breaking down into acrolein, produced industrially from propylene and mainly used as a biocide and is a building block to other chemical compounds such as the amino acids methionine. In the 20th century, acrolein became an important intermediate for the industrial production of acrylic acid and acrylic plastics. Acrolein is toxic and is a strong irritant. Connections exist between acrolein gas and the smoke from tobacco, cigarettes, and the risk of lung cancer. So if you're smoking and you're getting cancer, know that acrolein has something to do with it. Acrolein is one of 7 toxins in cigarette smokes that are most associated with respiratory tract carcinogenesis, and is also found in photochemical smoke, which we will talk about it later in the course. So this concludes the aldehyde parts. Let's go back to now our functional groups. So we covered alcohol, we covered aldehydes, we covered ethers. Next, we'll be talking about ketones, which is a carbonyl group, Here are ketones, and they are connected to R and R dash from both sides, similar to ethers. So can start watching this in a second.